Okay, Assalamualaikum and good evening to all my students. MEM341 uh, Fleet Power. So this is our last video. I will teach you about the chapter 10, pneumatic circuits and applications. Okay, so let's get started. Make sure you have these notes in front of you because all the 10 chapters notes already available in our Google Classroom. Okay, so uh, let's read about the first slide of the chapter 10. So in the end of this chapter, you have to know three outcomes. The first one is to know about the graphic symbols. Second one is basic pneumatic circuits, and the final one is pneumatic circuit applications. So uh, this chapter will be covered in the final test. So I want you, all of you, will master or know how to draw pneumatic circuits and also know the applications of the circuits. Okay, so let's go to the introduction first. Pneumatic system is a system that uses compressed air to transmit and control energy. So this is just introduction that you already know. So this is our last chapter, so make sure you have already known about the pneumatic system. Okay, so this is about the advantages and disadvantages of the pneumatic system. Basically, the advantage of the basic pneumatic system and disadvantage of this pneumatic system is already discussed in the chapter 5, 6, and 7. 5, 6, I think. It's regarding to the hydraulic system versus the pneumatic system. So this pneumatic system has advantages of the high effectiveness, high durability and reliability, simple design, high adaptability to harsh environment, and the fifth one is to have the economical and environmental friendly. But it also has the disadvantages. Basically, because of his high effectiveness and simple design, their accuracy is quite low compared to hydraulic system. Low loading, it's not that heavy duty compared to hydraulic system, and the processing required before use. Okay, so basically there are filters that have to make sure the air is pure and not contaminated. Uneven moving speed. Okay, this is the flaw or disadvantages of pneumatic system compared to hydraulic, because the hydraulic is very accurate and consistent speed. And finally, it may have high noise. Okay, so these are the examples of the components in pneumatic system. There are compressors, receivers, filters, pressure regulators, and so on. Okay, you can read by your own in this list. Okay, so let's get started to the graphic symbol. Okay, so there are some categories that categorize the symbol of the components. Okay, let's say this is for the energy supply. In this diagram, it shows that the compressor is symbolized by this symbol. Okay, this means that it is a compressor. This is the reservoir or tank. Okay, and this is just the pressure source. So you can use either one for your circuit based on your what is the energy supply in your system, in your design system. Okay, so make sure you have known the basic symbol of the energy supply, likewise in this diagram. Okay, Okay, this is the symbol for the maintenance component. There are filters, water separator, lubricator, and so on. So there are many others, the maintenance components. You can either check it in internet, or you also can try explore by your own using our software, Fluid Sim, right? Okay, I think okay, phase 2 Fluid Sims, this one. Okay, you can try by your own. There are many components here, and it also has the description and explanation for every each of components. Okay. Okay, so the next slide is about the combined symbols. So for application of pneumatic system, there will be more than one components that you have to combine. So this is just the example of the combined symbols that is normally found in a circuit diagram. Okay, this one is the air service unit. So basically, if we know this is found in your circuit, so uh, it combines all the components of the energy supply and so on in this symbol. So it will provide or supply the air for your pneumatic system. Okay, so let's go to the one of the most important symbol in our pneumatic system circuit. This is called the directional control valve, DCV. I know that DCV is already discussed in our hydraulic system in chapter 4, 5, 6, I think. So it is similar in this pneumatic system is similar to the DCV for the hydraulic, but basically because of the pneumatic doesn't have the written line, so it will have this symbol for their exhaust outlet, exhaust port here, because the pneumatic is just release air to the surrounding compared to the hydraulic that it will have to return the return oil or return hydraulic fluid to the reservoir and will be recycled in the loop again and again. But for the our pneumatic system, it will just it will release the air through the exhaust port here to the surrounding. Okay, so this is one of the significant difference between the symbol of pneumatic and compared to hydraulic system. Okay, so let's read the description here. The pneumatic symbol of a DCV is formed by one or more squares. Okay, the inlet and the outside exhaust are located at the bottom side of the square. Okay, so arrow indicates the flow direction of air current here, like this, the arrow. So it means that from the below port here, we direction to the upper port here, to the outlet port. If the external port is not connected to the internal port, the symbol T is used. Okay, T, this one. So this means that it is not connected. So there will no outcome or no outputs when it is connected to the T port. Okay. The symbol round and dot in the center of the circle like this represent the air input. Okay, this one. This means that the air input. Okay, and the rectangular symbol here, upside down rectangular symbol represent the exhaust. Okay, let's get a break for 5 minutes. I will continue after 5 minutes. Okay. Okay, let's continue with our chapter 10. So this is the directional control valve DCV, examples of some of the components that use the DCV. Okay, as we know that the rectangular box here represent the number of the way So there are two ports here, so means that there is two-way. And for the number in front of the name of the DCV here, represent the number of ports. So like this example, two ports and two-way valve, okay, normally open position because by default at its normal position, the direction is coming from the port 1 to the port 2 here. So if you actuate the DCV or switch the DCV, so it will change its position from the right side here to the left side here. Okay, so if the name of the DCV is two-way valve here, so it means that there are three ports, 1 2 3, 1 2 3, and two-way is two ports, so there is two way of the positions that can be chosen. Okay, so if you have 5 ports three-way like this, so we will have 3 ports three-way. 3 ports mean that three-way, and 5 ports here means there are 5 ports for each way, each box. 1 2 3 4 5. Okay, so it is similar to the DCV in hydraulic system that we have already learned in the chapter 4 5 and 6. Okay, once again, the symbol of the circle one with the dot at the center represent the air input, while the symbol of the upside down, the rectangular here, represent the exhaust. Okay, so this is the port designation. If we name this one is the port 1, port 2, and port 3. So for this one also we will have the port 1 here, port 2 here, and port 3 here. So it is the spring DCV here. If we change the position, we will have to compress the spring, so it will change the direction. 2 will become here, 1 will become here, and port 3 will be here. So if we release the actuation here from the port 12 port 12, it will back to the normal position because it is the spring connected. Okay, so there are many actuation of the DCV. Basically we have the manual, mechanical, and also electrical. So in this slide, it shows the manual actuation. The samples one are the general one, push button, lever here, lever with D10, and foot pedal. And for the mechanical actuation, we will have the stem, roller, spring, and so on. Okay, you can read the details here about the symbol of the DCV, directional control valve, DCV. Okay, I will leave it to you to read by your own, because this one you have to understand by your own, and by then you can master the symbol of the pneumatic circuit. Okay, so there are also the pressure control, flow control valve. Okay, so like this one is the non-return valve. Basically, the non-return valve is used to prevent the return flow. Okay, like this. Okay, this is the symbol for the non-return valve, or sometimes we call it the check valve. And this is the shutter valve. This one you will use it in the laboratory experiment of lab 5, I think lab 5 or lab 6 for pneumatic. And also similar to the dual pressure valve and function here, also will be used in the lab 5 or lab 6 experiment. Okay, the difference between OR and AND function here means that OR, if it actuates either one, it will have only one supply air here. But for the AND function, you must have both ways to functioning the control valve here. So if there is no air for the flow here, so there will be no flow outlet. Okay, so this is symbol for the flow control valve. Okay, as we know, if we have the direction of the arrow here, it means that it is variable, so you can vary your flow. So that's why it is called the flow control valve. Okay, so this is also the symbols of the pressure control valve. You can change or modify your pressure by using this valve. Okay, and this is the symbols of the actuators. You may be already familiar with these symbols that also used in the hydraulic system. Okay, so this one is for the single acting cylinder, double acting cylinder, and so on. Okay. Okay, this is the rotary drive. Also one of the actuation component. So you can use the rotary drive or linear actuator for your end outputs. Okay. So the basic pneumatic system, pneumatic circuits are similar to hydraulic circuits. That's a numerous time of I mentioned before. But the difference is that no return line are used in the no return line is used in the pneumatic circuits because the exhausted air is released directly into the circuits compared to the hydraulic system that we will have to return back the fluid return back to the tank. Okay, but for our pneumatic system, we just have to exhaust air to the atmosphere. Okay, so also there is no input device because pneumatic circuits use a centralized compressor as the source of energy. Okay, so basically we will have one main supply components, air supply component like this one, like this symbol. Okay, let's go back. Okay, this one, or maybe you just have to put this one, the air service unit, in your circuit drawing. Okay, so this one is the example how the pneumatic system operates based on your circuits. Okay, so this is the example of the basic one. We will have FRL. This is one of the what we call air service unit. Where is my pen? Okay. Air service unit, and this is the pressure control. Okay, so normally if we do not push the button here, the position will be by default like this. So air supply here will shut off by the T port here, so there will be no air supply into the single chamber cylinder, single acting cylinder here. Okay, so if we push the button here, the position will be changed from here to this one. So the supply will be connected to this one, and this one will be connected to this one. So the airflow will go into the single acting cylinder, and the piston will extend. Okay. Then if we release the push button, the switch button will retract back to the normal position. Okay, will be returned back to the normal position as the original position, and then okay, and then the cylinder air in the cylinder will go to this one and release to the surrounding. So dot line here means that it is exhausted to the atmosphere. So and then what happens to the cylinder? The cylinder will be retracted. Okay. So you can read by your own here. Okay. When the push button valve is actuated, the cylinder extends. Yes, just like what I mentioned before. And the cylinder retracts when the valve is deactivated. Yes, after you release the push button here, the air will be released to the surrounding, and because of the spring contained in the single acting cylinder here, it will push back the piston, retracted to the original position here, and then the air will be released to the surrounding. So needle valve V1 and V2 permit speed control of the cylinder extension and retraction stroke. So because of the V1 and V2 is a variable pressure control, so you can control the flow, and then by controlling the flow you can control the speeds of retraction and expansion. Okay, so this is the basic one, the example one of the circuit. Okay, so let's put this is just the extended version of the example one. It explains a little bit step by step, just what I explained earlier. Okay, let's go back to this. Let's go to the circuit 2 here. Figure 16, control of a double acting air cylinder. Okay, so for now the difference is we have different DCV and the different type of actuator, linear actuator here. So this one is double acting air cylinder. Okay, so this one is 1 2 3 4 5 5 ways, 5 ports, 2 ways directional control path DCV. Okay, 1 2 3 4 5. Yes, 5. Okay, double acting cylinder requires a 4-way deceiver. Actuation of the push button valve extend the cylinder. The spring offset mode causes the cylinder to retract under air power. Okay, so now we have the push button here and we have the spring here. So if we don't push the spring, if we don't push the button, so it on the normal position is on this way. Okay, the air comes from the air service unit here, air service unit, or sometimes we call FRL. Okay, supply air to the double acting air cylinder. Okay, when the air goes into the cylinder, it will push the pistons to the left side, or we call the retraction. So it will retract, and then the air here will be pushed outwards into the port 4 and then this is what we call the exhaust, and then it will release to the surrounding. So the position of the air cylinder is retract. Okay, what happens if we push the button of the DCV here? So the ways will change from the original position here to this second position. So from this, the air from port 1 will be supplied through the port 2 here. Okay, not port 2, to the port here, and then the air will enter into this one. Okay, it will push the piston, and the piston will extend. Okay, and then the air will exhaust back to the port 2 here, and then it will release. Okay, what happens if we release the button here? It will go back to the original position. The DCV will return back to this position, and then the cylinder will retract. So in the end, you have to conclude the summary of the response of the system, okay, by if we release the button, DCV button, piston retract. If we actuate the DCV button, piston extends. So in the test, this is the answers for the system outputs response. Okay, so the conclusion like I write here is the normal answers that you have to answer in the test or assignment. Okay, so that's the example of the circuit 1 and circuit 2. So you can try by your own for the example 2 and so on, because you have to imagine step by step for every operation of the system. Okay, so you need to have high imagination. If not, you will be faced the difficulty to understand the circuits drawing. Okay, I will leave to you to try by your own. So there are tutorial questions here that are provided in these slides. You can try by your own, and then you can check your results. I will put here in this video. So for the tutorial 1, the answer is cylinder extend and retracts continuously. You must try by your own. Okay, for the tutorial 2, the answers is for A, nothing is fully extended, extends and stops if fully retracted. And for the B, cylinder extend and retract continuously when V4 and V5 are both depressed. Okay. And for the tutorial question 3, the answer is cylinder 1 extend and then cylinder 2 extend. For the B, cylinder 2 retracts and then cylinder 1 retracts. So make sure you must try by your own for all these tutorial questions. Okay, please do by your own. You must try, you have to practice. Okay, you can try using the FitSim from the phase 2 software that are provided for you for the lab test, for the lab experiments. And you can try by drawing by your own using the different color of pencil, okay, or pen. Maybe the input you use the green color and the written use the red color, and try until you understand the circuits. I'll just use the Photoshop here, like can change the position of the PCV here to understand the circuit, okay, like this. But it can be used by the manual, by drawing by your own, okay. So it depends on your creativity how to simulate the basic the schematic drawing here. Okay, so that's all for this video. So it means that this is the final video of our MEM341, and then at the end of this chapter means that we have already completed our MEM341. Then so thank you. Saya minta maaf if I have done wrong for entire class for this semester, and good luck for you. We will have to have a test, final test at the end of the semester at the 14 weeks, 2 weeks from now. And also you also have to submit me an assignment. So there are 2 more assessments that you have to complete it. Final test at the final week, and also the assignment you also have to submit at the final week, the 14th week, 2 weeks from now. So that's all. Thank you. Assalamualaikum. Good luck, and see you in the future. Okay, bye bye.